All right, well, the Mickey Mouse show has already started because I forgot to hit record. But basically, what we're talking about for my YouTube viewers, none of them, is when the cosine rule is useful, side, 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 side angle, side, and you could solve for the rest of the triangle. And sine rule, one side, I don't know why there's an S there, one side and two angles, angle, angle, side. Or two sides and a non-included angle. That's the one that would be angle, angle, or angle, side, side. If you had two sides and a non-included angle. So we'll say side, side, angle. So I don't have to write angle, side, side on my paper. But you need to be careful of the ambiguous case. Remember, sine is positive in two quadrants, quadrants 1 and 2. So how do you know when it happens? I talked about it yesterday, but that video broke, so I didn't get to post it. But how do you know? Is when you are solving for the larger angle. And that's the only time where ambiguous case can happen. And that's it. When you are solving for the bigger angle, look out, there's two answers. So now, let's put it all together. The angles of elevation to the top of a mountain are measured from two beacons, A and B at C, which you have A here, B there. Okay. The measurements are right there in the diagram. If the beacons are 1,473 meters apart, how high is the mountain? So I know this number right here, 1,473. And I know that I'm looking for the height of the mountain. And yes, this is enough information to find that height. So how do we do it? Well, there is a trig way of doing it, the way that I do with my pre-calc students, that involves a system of equations. But there is a way that uses our current knowledge to tackle it. So what are we going to do? This is what we're going to do. Oh, you got an idea for me?
Yeah, so where we have our angle at 41,
Yeah,
we
yeah.
know that's a straight line.
Yes, this is a straight line.
We can find that with angle.
This angle, you mean?
Yeah.
We can find that angle, yeah. Which means you can also find this angle.
Yeah.
Yes. So that's what we're going to do first. We're going to play an angle game. We can find this angle because this is a triangle, and all triangles add up to 180. And we can find this angle by the same logic. So let's see. Right here, this angle is the supplement of 41.2, which is 138.8 degrees. I like to write my angles in red. So let me see. 138.8 degrees. That's what's going on right there. Right there in this obtuse angle. That gives us the ability to solve for this angle right here. This is known as angle ATB. The measure of angle ATB, remember the middle letter is the one you're talking about, so ATB is up here, is 180 degrees minus the two angles that we know, which are 29.7 degrees and 138.8 degrees. Through the magic of the notes sitting next to me, I could tell you that that is going to be 11.5 degrees. So right, let me see, 11.5 degrees goes right there. 11.5 degrees. So how is this useful? Well, let's problem solve for a moment. I know I'm trying to find this height, and I have this angle associated with this height. If only I had another piece of information in this triangle. I need another side length in this right triangle. Because if I had another side length in this triangle, I could use basic trigonometry. Because sine of 41.2 is going to give me h over this. So if I had this length, I could use sine. And tangent of 41.2 is going to give me h over this. So if I had this, I could use tangent. But check out what I have. I have angle side angle. That's another version of, whoops, you can't see it, angle angle side. So I can use the sine rule in this skinny triangle to find this hypotenuse right here. And we'll call it, let's give it a value, a variable, I mean. How about we could just call it x? You guys cool with that? Let's call it x. X, just like that. Okay. I'm trying to solve for x now. So since I wrote x in green, I'll do all this work in green for solving for x. I know that side length x over sine of the angle across from it, so we're using the sine rule here, sine of 29.7 degrees, is equal to side length 1473 divided by the sine of the angle across from it, which is 11.5. So we can solve for side length x simply by multiplying both sides of that equation by sine of 29.7 degrees. X is 1473 sine of 29.7 degrees, all divided by sine of 11.5 degrees. And again, by the magic of the notes sitting next to me, we get the number 3660.62. 3660.62. Oh, hey, I know this number. Well, shoot. Sine is now my buddy, opposite and hypotenuse. Because sine of this 41.2 degrees would have been h over x, but I know x. So h is x times the sine of 41.2, so h is this number, sine 41.2 degrees. H is 3660.62 sine of 41.2 degrees. Which yields 2411.21, and our unit was meters, if you care. Is that the only way to do this question? No, it's not, actually. There's a much harder way to do it that I make the pre-calc kids do, but that's not you. The harder way involves a system of equations and tangent.
Why would you make them do that then?
Because they haven't learned the sine rule or cosine rule yet. It exists in a different part of their textbook.
That's technically
What's that? No. You can't say easier. You also can't say that this one's easier. It's completely different. The way that I would say it is there's a lot more material to learn in the pre-calc and trig course. A lot more material, but the understanding of that material is more rote. You know, it's just like, okay, I can mimic basically what my teacher did. I memorized my special right triangles, you're good to go. Whereas in this class, there's less material to learn. Our notes are usually much shorter, but the way in which you must understand the material for this course is much different.
I would suggest then that we could say that that class is more, that this course is more rigorous, solely dependent on the difficulty of the content itself relative to the other course, not upon
Yeah.
quantitative material.
But I will say that that class, they do learn some harder math that we don't do at this level of IB math. But again, their tests are, look, could you crunch the numbers like I taught you to? Whereas your tests in this class are like, hey,
Do you know what you're doing?
did you know what any of that meant? Could you apply it in a weird way? You know, so
IB is essentially every time you ask.
yeah, the reviews, yeah, the reviews looked exactly like the test, just with different numbers. Now the tests weren't easy, and the reviews weren't easy, but this style of testing in IB. Oh, Michael, you done? Okay. The style of testing is what makes this a challenging course. Yes, sir.
You said we're going to use the cosine rule in that problem in the beginning. Did you use it?
I didn't use the cosine rule. I didn't have to.
Okay.
Now sometimes you will. Sometimes you'll have to use both. Did I say I was going to have to use both?
You just said something about using both.
Well, sometimes you have to. I can tell you for this one, I'm pretty sure I do have to use both.
Okay. I just got this one.
Sorry. Oh, very interesting. This example is not in my notes. I have a completely different example, which means I was unhappy with the example I had and switched it out for this one. Now, anybody that had me last year has done this question before. So, to approximate the area of a lake, Cindy walks around the perimeter of the lake, taking the measurements that are shown in this illustration. Using this technique, what is the approximate area of this lake? Now, obviously, it's 3 triangles. So what we are going to have to do is find the area of each triangle and add them up. And because we don't learn Heron's rule in this course, we'll actually have to work a little bit harder than my pre-calc kids would have had to. Nope, Heron's rule is not part of this program. That doesn't mean you're not allowed to use it.
Yeah, I was just gonna say, if I had.
It's not in the mark scheme, I can tell you that. But if you use mathematics that is used correctly, then it's just considered another method. So yeah, the graders that grade the exams have to be, they grade the math tests, have to be math teachers of IB math. I know because I applied. So fingers crossed. But yeah, you have to know the mathematics in case a student uses another method that works. You have to be able to follow it. Like a couple years ago, Michael Rainey, no, he's right here. Michael Belansky, sorry, wrong Michael. Was it Belansky or was it Wardlaw? It might have been James. I think it was, now that I said, I think it was James Wardlaw. He did a question on the test that you guys are about to get, either this chapter or next chapter. And it was so ridiculously difficult the way he did it because he forgot something very basic, but it worked. And I had to follow his work. I was like, good gravy, look at everything you did. But every step was correct. It's a good thing I used to teach geometry, like I remember all this stuff, but wow, that's crazy hard what you did, but it worked. So yeah, it's okay. All right, so anyway, we've got this lake. Okay, well, how about we call them like area 1, 2, and 3? Can we do that? Make life simple? So we'll say that this big one here is area 1, this one's area 2, and this one's area 3. Now, I am really happy about this setup because areas 1 and 3 are very easy. And the reason why they're easy is because we have an area formula for a triangle that uses side angle side. It's in the reference sheet. Area 1 can be found using 1/2 AB sine C because I have side angle side. So area 1 is going to be 1/2, 100, 125, sine of 50 degrees. We grab handy dandy calculator. No. The big area is 4787.78. I like 2 decimals. 4787.78. Now, we can find area 3 in the exact same manner. And since I have all these lovely colors, area 3 is going to be green. 1/2 AB sine C. Clearly, A, B, and C are just placeholders. 1/2, 50, 70. Sine of 100 degrees. That equals some number I don't know. Yeah. I know all the numbers. Let's see, 25 times.
Have you seen the thing that's like, oh, you like math? Name all the numbers.
Yes, I've seen that.
Yeah, it was negative, maybe positive.
Yeah. Got him. Yeah. 172.3.41. Yeah, it's like, yeah, you thought you were gonna get me? Name all the numbers. Very simple. Negative infinity to positive infinity. Yes, sir. Yeah, I just needed the calculator to fit in the screen. All right. So we're ready to rock and roll on area 2. Now, if we knew Heron's rule, then we could use the cosine rule to find this side length and that side length, and then just use Heron's rule to find this area. But we don't know Heron's rule. So what are we going to do? Well, we're still going to use the cosine rule. We're going to use the cosine rule to find this side, and we're going to use the cosine rule to find that side. And in order for us to find the area of the triangle, we're going to need an angle, aren't we? I will then be forced to use the cosine rule again in this triangle to solve for an unknown angle. Then I would be allowed to do this. So yeah. Yeah. Oh, I thought you were raising a hand. Okay. What color do I want to use? Purple feels good. I like purple. So let's say area 1, its cosine rule is setting us up to do that. And area 3's cosine rule is setting us up to do that. I don't remember if you did or not. My favorite color is black. So cosine rule. Oh, I guess I have to name these side lengths, don't I? So I want to call them X and Y? How's that feel? X and Y? Yeah, Steve and Bob. Okay, I'm calling them X and Y. So y squared equals a hundo squared times 125 squared plus, sorry, not times. I'll be okay. Just a small stroke there. Minus 200 125 cosine of 50 degrees. So y is the square root of all that stuff. By the way, don't write all that stuff on your questions for the IB exam, please. But that's what my teacher taught me. Yeah. Yeah, this is new. This is math symbols.
All that stuff.
I should create a new symbol that means all that stuff. Minus 2 times 100 times 125.
What's the Z looking thing?
The element of Z.
No. Sigma.
Sigma.
Sigma's essentially saying all that stuff, but added.
Yeah, it's saying add all that stuff. Wow. Oh, that's because I haven't taken the square root yet. I was like, that's a really big number. So I need to take the square root of all that stuff. Second square root of my second answer is a more appropriate number, whew, thank goodness, of 97.75-ish. This is supposed to say X, not Y. Sorry, I used the wrong letter. I know. 97.75. Luckily, I caught it before everything was said and done. I was solving for this, which is X. The cosine rule is on the formula sheet, yes. And the sine rule, yep. And the area of a triangle formula. Yep. I'm sorry?
Is there anything?
For the upcoming test, you need to know your special right triangles. You need to be able to evaluate trigonometry. And you need to know where the trig ratios are positive and negative.
I just meant formula-wise.
No, formula-wise? No formulas have to be memorized.
Yeah, you have to remember how to do it.
All right, cosine rule number 2. This one's actually going to be finding the y value in this picture, which is right here. So I'll be using these 3 pieces of information to find this y value. Okay, y squared, new color, because rainbow, y squared equals, actually y this time, 70 squared plus 50 squared minus 2, 70, 50 cosine of 100 degrees. And then y clearly would be the square root of all that stuff. Since we've written all that stuff once on the paper, we'll just assume that we did all that stuff again. 70 squared plus 50 squared minus, yikes, what is that? 2 times 70 times 50, uh-oh.
I'm guessing all that stuff.
Second, insert, parenthesis, there we go. Parentheses, cosine of 100 degrees, I'm in degree mode, is a big number. But of course, we need to take the square root of all that stuff, right?
I'm assuming that would be marked as bad method on a test.
If you wrote square root all that stuff, yes, that would be bad method. Got a side length of about 92.82.
I gotta find the symbol for all that stuff.
Okay,
If I said that,
I'm.
if I said all that.
If you said all that,
If I said, no, if I said the expression equal to.
yo, yeah, you said it equal to a variable.
Yeah.
Yeah, you'd be like, let all this crap equal b. Yeah, then you'd be fine. Mathematicians do that stuff all the time. Or e equals mc squared. M and c, even though they represent things, it's also another version. It's a bunch of collapsed formulas into be like, it's just easier to call this m, and it's easier to,
Well, yeah, the M part is.
Yeah, yeah.
The C part.
Yeah, but the C part's kind of C. Can't do much about it. I think E is a bunch of collapsed formulas too, isn't it?
Well, that's what alpha.
Yeah, but I mean, it can be written as a bunch of.
There's a bunch of ways to notate E equals MC squared, but I'm just saying C squared is kind of like that as a constant.
Yeah, C
And
can't do
it's
much
the
about.
whole mass.
So here's what I'm going to do because this stuff's getting a little convoluted. I'm going to write down the measurements that we have on this triangle. I have 97.75 here, and I have 92.82 here, and this is still area 2. We are still trying to find area 2. But I do have side, 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 and I can use side, side, side to find an unknown angle using the cosine rule. And because I have all 3 sides, it actually doesn't matter which angle you find. It's unimportant. So what do you think about me putting theta right here? What do you think? Awesome. So in order to solve for theta, I will use my cosine rule set up like this. So theta points at 92.82. 92.82 squared equals 50 squared plus 97.75 squared minus 2 times 50 times 97.75 times the cosine of 92.80. What have I done? Theta. Cosine of theta. Sorry. That was supposed to say cosine of theta. I'll be okay. Man, I'm trying to isolate theta. I gotta do a lot of work for this. I'm not gonna actually compute this stuff. It's not worth writing the numbers down. I'm going to subtract this and this.
Oh, I see what you're doing.
So 92.82 squared minus 50 squared minus 97.75 squared equals negative 2 times 50 times 97.75. Man, if we had Heron's rule, we'd already be done. Cosine theta, it's not part of the curriculum. I don't have time teaching, so aren't in the curriculum. Divide by this mess to get cosine theta by itself. Ugh. Not happy about this.
Okay, what did you do right before that?
I subtracted these two numbers from both sides.
Okay.
Here's me dividing by that stuff that's sitting next to cosine. It really is awful.
I feel like the IB, you have to show all this stuff.
They would want to see it all. But by the way, this is not an IB question. It's a pre-calc question.
Well, yeah.
But the one I had in my notes, I didn't like anymore. So, you know. Now, theta is equal to cosine inverse of all that. So there's another, wow.
Yeah. Let me just take the L on this one.
Just take the L? You better not.
I'm gonna take those.
Again, this question is not an IB question, and we're not doing it the way this question was intended to be done. This question was intended to be done with Heron's rule. So I'm just going to take this one step at a time, okay? One step at a time. 92.82 squared minus 50 squared minus 97.75 squared is divided by negative 2 is divided by 50 is divided by 97.75 is, and we have to do cosine inverse of that.
We got it. We got the angle, guys. We did it.
Now that we have the angle
Now we don't
at 69.4 degrees,
And that's the class, guys.
yeah.
You just like picture that, crop it, upload it to our.
Now wait a second. Whoa. Now we have to find area 2 and then add all three areas together.
Why?
Because that's what the question said.
Yo, what was that line at the end of Endgame to Captain America? No, I don't think I will.
Area 2 is 1/2 50 times 97.75 sine of 69.4 degrees. Okay, we're almost there, guys. We're almost there. It's like this one was a marathon. It wasn't a sprint, okay? 25 times 97.75 sine of 69.4 is, I said is. Why is this number so big? No, they weren't. Oh, it's an area. It's an area. Okay. Whew. I thought I was having a stroke for a second. I was like, oh my God, what have I done? So 2287.5.
It's right in between the amount for area of ordinary.
Yeah. I was thinking it was a side length, and I was like, holy cow, what's wrong here? And last but not least, A equals A1 plus A2 plus A3, which is, we're just going to write our answer. So 4787.78 plus 1723.41 plus 2287.5 is, at long last, guys, 8798.69. Mic drop.